Okay, so up till now we've been writing reactions. We've been looking at oxidation and reduction, which compound or which atom was being oxidized and which was being reduced. But you know enough from chemistry to know that just because you can write a reaction down doesn't mean it's actually going to happen. There's that whole question of, is the reaction spontaneous or not? When you put these things together, will it actually happen? Now, we know that some of them will, and we know that some of them need something to help them along a bit, a catalyst. Some of them might need heat or stirring, and some of them are going to be spontaneous on their own, and some are going to be non-spontaneous. So how can we tell? Right? So not all reactions happen spontaneously. How do we tell? Well, one way we can tell is experimentally, right? So we can do an experiment. Mr. Jewett and all other chemistry teachers are twitching a little. We can dump different things together and see if a reaction occurs. It's probably not the best way, but we can do it in a controlled way. So one experiment that we could do was that we could take copper metal, lead metal, silver metal, zinc metal, and we could place them in beakers of their ionic solutions, their metallic ionic solutions. So copper nitrate, lead nitrate, silver nitrate, and zinc nitrate. Now, of course, you know if there is solution, then this is really Cu2 positive aqueous that has dissociated from the NO3 complex or polyatomic ion, which is going to be a spectator. The same for the lead. It'll be Pb2 positive. That'll be working here. Silver Ag positive. The NO3 will be a spectator, and the same for the Zn2 positive. So when we do this, what we discover is that the copper solid doesn't interact at all with the copper nitrate. That's not a surprise, right? Doesn't interact with lead, but there is evidence of a reaction with silver. So the check mark means an evidence of reaction and nothing with the zinc. Lead reacts with the copper nitrate and with the silver nitrate, but not with the lead and not with the zinc. Silver doesn't react with anything. Zinc reacts with the copper nitrate, the lead nitrate, the silver nitrate. The only one it doesn't react with, which is itself, which makes sense. So if you take a look at this, really all of these metals are being oxidized, right? If they react, they're being oxidized. They're becoming their metal ions. So if they're being oxidized, then these guys are the oxidizing agents. And so we could look to see which one of these is the strongest oxidizing agent. And remember, we're ignoring the NO3. It's spectators, so it's the Cu2 positive, Pb2 positive, Ag positive, Zn2 positive that will be the oxidizing agents. Which one is the strongest oxidizing agent? The one that causes the most of these to react. It would be silver. And so we could write the half reaction for silver as an oxidizing agent. It will be Ag positive plus 1 electron going to Ag solid. And of course, this would be aqueous. Okay, so that's what its half reaction is going to be when it causes these to become oxidized. Which one is the next strongest? It'll be the copper because it has 2 check marks. So Cu2 positive aqueous plus 2 electrons going to Cu solid. Which one's the next? The lead. So Pb2 positive aqueous plus 2 electrons going to Pb solid. And then the last one would be the zinc. Zn2 positive aqueous plus 2 electrons going to Zn solid. So these are all half reactions for oxidizing agents. This guy is the strongest oxidizing agent, and as you go down, they get weaker. Now we could also say, well, the oxidizing agent is actually being reduced. So these ones are the reducing agents. So which one's the strongest reducing agent? The zinc. And it's down here at the bottom. So this guy is the strongest reducing agent. Which one's the next strongest? The lead. And look, he's next. and then copper. Oh, he's next, and the weakest is silver, and so the strongest reducing agent ends up on the bottom of the chart, and they get weaker as they go up. Okay, so we always write it, and what we could do is create a chart so that next time we wouldn't have to do the table, we could look on here. So we always write it with the strongest oxidizing agent on the left-hand side. The electrons always get added on the left-hand side, okay? And the reducing agents are on the right, and so the strongest is oxidizing agent is in the top left-hand corner. The strongest reducing agent is in the bottom right-hand corner, okay? And so what can happen then is we can do a whole bunch of these experimentally, and then we can put our charts together and get one big chart. So then when someone says, which one's the strongest reducing agent, silver or zinc, I don't have to go and do the experiment. I can look at the chart. Okay, so today you're going to use this chart that we just made, and the chart from exercise 12A. It's similar. You're going to do a similar exercise just with a different chart, and then lab exercise 12B. You're going to get a third chart, and then the last step asks you to put the chart that we got from here, that we just did in this example, together with the chart you created from exercise 12A and the chart you created with exercise 12B into one big chart. So that last step is going to take a little bit of logic. So we'll see who's good at logic. Okay, so try that one tonight, and tomorrow I'll show you a new way to make a chart.